This is how you calculate expected monetary value using a decision tree. I'm using data from problem 5.13 at the end of chapter 5. So if you want to take a look at that data and follow along, that would be great. You can use Excel several different ways to solve this problem. One approach, and I give you an example out on Canvas of doing it vertically using columns. I'm going to do this horizontally so you have an example of that. I don't care how you lay it out. Basically, you're just using Excel to do the calculations. If you want, you could do the picture on a scrap piece of paper, but you're not asked to hand that in. You're simply asked to decide which has the best expected monetary value. Now, one thing you always have to keep straight with expected monetary value is whether it's a cost model, then you want the one with the lowest expected monetary value, or if it's a profit, where you have revenue and then you subtract cost and you figure out what the profit is. Of course, on a profit model, you want the highest expected monetary value. And so for your homework, you have both a cost model and a profit model. So remember what you're looking for, either the lowest expected monetary value if it's a cost, or the highest if it's a profit model. 5.13 is actually a profit model. What you have here is, I'm going to lay this out horizontally like I said, but there is also an example posted out to Canvas for this very same problem where I did it vertically. What you can imagine is if you took this data and you flipped it on its side and put it down the columns, and then calculate the expected monetary at the bottom of each of the columns. Doing this horizontally, you have to kind of spread it out but this would correspond much more to the picture that you may have created in your mind. So what we have here is a profit model. An individual has the idea to be able to produce a framed print of the Mill River when it freezes over. People go ice skating on it, and so he's going to produce this print, this picture of that, and he has a couple options. He's looking at an elegant option and a deluxe option, and of course he can do nothing. He's not required. Now, some of the homework problems or some of the problems you see in here, that option is not on the table, that you have to make a decision. But in this case, because we're looking at the introduction of a new product, he can choose not to introduce a new product at all. Of course, the expected monetary value of that is pretty straightforward. It's zero. Nothing ventured, nothing gained. So, but you want to consider that if both of these are negative, in regards to profit, then we better do nothing. But he has two outcomes for each one of these. So he could do the elegant print, and if the market's good, he feels like he can sell 400 of those at $125. If the market is bad, he feels that he can only sell 300 at $90. If he decides to do the deluxe one, if the market's good, he can actually sell 500 of those at $100, and if the market's bad, 400 at $70. Now we need some other things here that we'll get from the problem, but let's first of all calculate what the total profit would be for each of these options. So this one, 400 framed prints times $125 for each one would give him a profit of, or revenue, I should say, because we haven't subtracted costs. So revenue of $50,000. And we can do the same thing here. If the market's bad, he's only going to sell 300 times 90. That would give him $27,000. Let's say he does the deluxe one. If the market's good, he can sell 500 times 100. That would give him $50,000, and if the market's bad, only sell 400 times $70, and that would give him $28,000. Now we need a couple other things. The other thing we need is to know what the costs are because this is actually a profit. We figured out the revenue for each of the options, and they say that the production cost for these is $35,000. And it doesn't matter, of course, the elegant is $35,000, whether the market is good or bad. What's interesting here is they said that for the deluxe, it's $35,000 as well. You would assume the deluxe would be a little bit cheaper on the production costs because it's not as fancy as the elegant. But you simply go with what the data they told you. So whether we're producing the elegant or the deluxe, it's $35,000. So now we can figure out the profit. So we take the revenue and minus the production cost. That is what we would make if we did the elegant and the market was good. We would make $15,000. Once again, revenue minus the cost. So if we did the elegant but the market was bad, we would actually lose $8,000. So let's take a look at the deluxe. So we have our revenue, we minus our cost, we make $15,000, and we go down here and same thing. If the market was bad, we bring this in and we would subtract our cost, and we'd lose $7,000. Well, we have kind of an interesting decision here. So we're hoping the market's good. Whether we do the elegant or the deluxe, we would make $15,000. If the market's bad, we would lose less money on the deluxe as compared to the elegant. And of course, if the market's bad and we did nothing, but here's where probability comes in. And what they have told us is that there's a 50-50 chance, and you simply go with it. And so if there's a 50% chance that the market would be good, 0.5, there's a 50% chance that the market won't be good or will be bad. And that's the same thing here. So 50% and 50%. So they don't always have to give you the probabilities, but the probabilities for every single one, but the probabilities should add up to 100% or 1. And so sometimes in this case where you have two outcomes, good and bad, they really only had to give us one, and we know what the other one is because it has to add up to 1 or 100%. Sometimes they'll have 3 options. You'll have a good, a middle, and a bad, and they could give you 2 of those probabilities, and of course what's left would be the third probability. Oftentimes they'll give you all of the probabilities, but you need to make sure they add up to 100% of the possible outcomes. And so what we can do now is we can actually calculate expected monetary value. So I'm going to put it out here. If we were to do the elegant version, what it is really we're taking into account these weight. We're doing a weighted average if you really think about it. And so there is a 50% chance that this option will happen, but there's a 50% chance that this will happen. And so what we do is we simply take those options, the 50% times the outcome, and we will add to that the 50% times the outcome here. Let's make sure we got parentheses around those. So they multiply by the probability first, and then you add those up. So if you had more options or outcomes, you would simply multiply them by the probability of them coming true, and then you add those all together. And that gives us an expected monetary value for the elegant of $3,500, because the real truth lies somewhere in the middle. Yes, there's a probability that 50% or 50, there's a 50% probability the market will be good, and there's a 50% that'll be bad. And so we multiply by those outcomes and then add those together. And so we can expect the elegant to overall be $3,500. Now we'll do that the same thing for here for the deluxe. the EMV is equal to, so once again we have this probability 50% that this outcome will happen, and we're going to add to that the 50% that this outcome, or whatever the probability is, times the outcome. And that gives us 4,000. And so if we had to make a decision, remember this is a profit model because we have revenue minus cost, and so we're left with a profit, and then we're multiplying those profits by their probability. The expected monetary value of the elegant, given the two probabilities, is 3,500. The deluxe is 4,000, and of course doing nothing is 0. So we would do the deluxe because it is the highest of the three things that we're looking at. If we were doing a cost, you simply add up the cost and then the probability of that total cost added to the other possible outcomes or the other possible costs, and then you would want the lowest expected monetary value. But because this is a profit model, we want the highest. Out on Canvas, you'll see an example of this done vertically. I could take this data and sort of flip it on the side and do good down a column and bad down a column for elegant, and then I could do deluxe, the good, and the bad down the column. I don't care which format you use, whatever you think is comfortable in laying it out, because really all we're doing with Excel is using it to calculate these expected monetary values, identify what are the various outcomes and then the probabilities, and those added together give you the expected monetary value for that option. There's also another example out there on Canvas, I believe, for another one of the homework problems. So I give you two examples in Excel. They both use the vertical method, but I wanted to provide this horizontal method, which corresponds more to if you were to actually draw it out. And that's the only tool that you'll have in Chapter 5 that you need to know.